Today's lesson is section 6.4, which is using the elimination method, but with multiplication. So it's actually just going to add one step to the problems you've already completed in section 6.3. So in section 6.3, if you took notice that either your x coefficients or your y coefficients both had either the same value or opposite values. And since they did, we were able to just add or subtract right away. But those types of problems were purposefully made that way. And now when we look into it, not all questions are going to have either the same or opposite coefficient values for either variable. So if we look at example 1, our x coefficients are 2 and 3. 2 is neither the same as 3, nor is it the opposite of 3. So then we would move on to our y's. The first y coefficient is 1. The second y coefficient is 2. 1 and 2 are neither the same or opposites. So now we're at sort of a dilemma. So what we would do is we actually will have to multiply either one equation or both equations to create terms that are the same or opposites. So if we are looking at these first two problems here, that's what I was referring to in saying that the x values are not the same or opposites and y values are not the same or opposites. But if I notice my first y coefficient is a 1, well, 1 is easily changed to any other number by multiplying. So I could make my top 1y become a 2y if I were to multiply it by 2. So I'm not allowed, though, to just multiply one term. I have to multiply every term. So I need to multiply every term by 2. So when I do that, so that was my first step, multiply 1 or both equations. Okay, multiply either one or both. In this case, we just had to do one. So when I do that, my top equation becomes 4x plus 2y equals 46. So notice how 2 times 2 is 4, 2 times 1y is 2y, and 2 times 23 is 46. Okay, so there's me multiplying it. My next step is to write both equations together and solve like we did yesterday. Now I have these two terms that are the same, and if they are the same, then we need to subtract. Okay, so in solving this, I'm going to get 4x minus 3x, which is 1x, equals 46 minus 37, and that is going to give me 9. So 1x equals 9, so just x equals 9. Okay, now my next step, or my third step, is to find y, or solve for y. So you could substitute it into either of these equations, or you can substitute it back into that original one. I'm going to substitute it back into the original problem because my y doesn't have any coefficients in front of it. So now it's going to be 2 times 9 plus y equals 23. So 18 plus y equals 23. And 23 minus 18 is going to give us 5. So this solution, because remember it's an ordered pair, is 9, 5. So the only thing that was different from what we did in section 6.3 is that very first step to multiply. So take a moment, try the your turn, and then come back and check your answer. All right, so there's the first your turn when we had to multiply one equation. We got 5, 1 as the solution. All right, moving on to example 2. Let's always start by looking at our coefficients. We have 4 and 3, 3 and -5. None of them are the same, none are opposites, and none of them have a coefficient of 1. So therefore, we are going to have to multiply both equations. Now you do have two options here. You need to make a decision. Do you want to eliminate your x values or eliminate your y values? One person could eliminate x, the other person eliminate y. The equations would look completely different, but their final answer should be exactly the same. For me, I am going to choose to get my y variables to be the same, and I will tell you why. I could have done x's. That actually would have given me smaller numbers to work with, but I'm choosing my y's because they're already opposites, and I prefer to add rather than subtract like we had been doing. So since one's a positive, one's a negative, if I get those coefficients to be the same value, they will be opposites then. So in order to do this, all we have to do is the number that 3 and 5 both have in common is 15. So I need to multiply my top equation by 5, but my bottom equation by 3. So my top equation will be 20x plus 15y equals 40. My bottom equation will be 9x minus 15y equals negative, let me double check. Yes, negative 69. So now my y values are the opposite of one another, so we are going to add. (20x plus 9x is 29x. My positive 15 and negative 15, they cancel. And 40 minus 69 is going to give me negative 29. Divide both sides by 29, and we get x is negative 1. So now I'm going to substitute that back into either equation. I'm going to substitute into the top one. So I'm going to get 4 times negative 1 plus 3y is equal to 8. So negative 4 plus 3y equals 8. So add 4 to both sides. 3y is equal to 12. And then y is going to equal 4. All right, for your turn, again, neither coefficient is the same, so, and all 4 of my terms are positive, so I'm going to go ahead and choose to get my x terms the same. So I'm going to multiply my top equation by 2 and my bottom equation by 3. So I get 6x plus 4y equals 20, and 6x plus 15y is equal to 9. Since they are the same, we're going to have to subtract. So my 6x's cancel. 4y minus 15y is negative 11y, and 20 minus 9 is 11. So y is going to equal negative 1. And then substituting that back into, I'll do the top equation. I get 3x plus 2 times negative 1 equals 10. 3x minus 2 equals 10. 3x equals 12, and x is going to equal 4. So the solution for the second your turn should be 4 comma negative 1. All right, our last example. It says John has 30 science fiction and mystery books. 4 times the number of science fiction books minus the number of mystery books is 5. Which systems of equations can be used to find how many science fiction books, which is F, and mystery books, M, he has? So he has 30 total books. So to get those total books, I have to add my fiction plus my mystery, and that should equal 30. So if I look, that equation is the same in all 4. So that part doesn't really help. But it says he has 4 times the number of science fiction books minus the number of mystery books. Okay, so 4 times the number of science fiction books, so 4F, minus the number of mystery books is 5. So if we look at that, it appears that the correct answer here is B. So take a moment, try the your turn. This one you have to write your own equations. But I want you to pause the video and give this one a try. All right, so the 2 equations you should have come up with should match those. And then once you make sure